Welcome back. Let's now talk about working with the BigInt. So let's now meet one of the primitive data types that we never talked about before, and that is the BigInt. So BigInt is a very special type of integer, and that was introduced in the year 2020. So let's quickly take a look at it. So we learn in the first lecture of this session that numbers are represented internally as 64 bytes, and that means they are exactly 64 ones and zeros. So to represent any number now of the 64 bits, only 53 are used to actually store the digits themselves. The rest are for storing the position of the decimal points and the sign. Now, if there are only 53 bits to store the number, that means that there is a limit of how big the number can be, and we can calculate that number. So let me just say here console.log 2 into 53 minus 1. So here when we run, so we got our output here, right? So this is the gigantic number right here. So this is essentially the biggest number that JavaScript can safely represent. Okay, so this here it's 2, right? Because again we are working with the base 2, which has only zeros and ones, and that is, and this number is so important that it's even stored in the number name safe. So let me just show you that here, console.log number dot max safe integer, this one. See here, when we run this, we get the exact same number. So any integer that is larger than this number, it is not safe. That means that it cannot be represented accurately. So let me just duplicate this for now and show you. So for suppose if you just put it here plus, see here it is supposed to be 993, but here it is giving 992 only. You see that this is not correct, right? So it only adds one number to this one where it should have added two. But if we do this, then we keep getting the exact same thing. So we keep adding numbers here as they were always the same. So this means that JavaScript can simply not represent these numbers accurately. So if we do calculations with the numbers that are bigger than this, then we might lose precision. Okay, so in some numbers it does actually work for some reason. That's just because JavaScript behind the scenes use some tricks to still represent some of the unsafe numbers. But again, sometimes that works, sometimes it doesn't. So that's why we call these unsafe numbers. So let me just show you here a few more examples. So here, let's just say 2, 3 and 4. So when I run this, as you can see here, it is not accurate. So you see sometimes these numbers or at least looks correct and sometimes they don't. Okay, so this can be a problem sometimes, because in some situations we might really need big numbers way bigger than this one. Okay, for example, for database IDs or while interacting with the 60-digit numbers, these numbers are actually used in other languages. So we might, for example, some API get a number that is larger than this, then we have no way of storing that in JavaScript, at least not until now. But now, starting from the 2020, a new primitive was added, which is called BigInt. Right now, BigInt stands for big integer. It can be used to store numbers as large as we want. So no matter how big, all right. So let me just show you that here. Console.log. For suppose here we are having some big number. So you see it doesn't have precision because it's larger than the this number, right? But if we use the n and then if we use it will be a big int. So right now we'll just copy this once more and then we'll paste it, and then here we'll just simply add n, so that this will be the big int. So when I run this, see here we got our output. This is the previous one, wrong one, and this is the using the big int. So you see the n here basically transforms a regular number into the big integer number, and it also console logs differently, as you can see here. Okay. And but now JavaScript has a way of finally displaying the numbers here accurately, right? And we can also create BigInt using the BigInt function. So sometimes that's necessary, and then without the n. So let me just show you that. So here console.log BigInt of. So for suppose, let me just copy this. See here, when we just copy paste this and then when we run without the n, as you can see here, initially it was fine, but after certain numbers it gets changed. Okay, so this construction problem probably should be used with the small numbers like this. Let me just show you. So we'll just remove these. So when I run this, see here, it works perfectly fine right now. So this is how we create big int numbers, but let's now see some operation with these numbers. Well, basically it's very simple. All the usual operations still works the same. So here, let me just write operations. So right now here we'll just console.log this, and then here we'll use the 10,000 n plus 10,000 n again. So when we run this, as you can see here, we got our value 20,000 n. It works now. So it is true for the other operations as well. So let me just show you that. So console.log, when we give some huge number, for suppose like this number, for random I'm just taking, and then n plus, then here you take some 10 and some random n value. So when you add it, so when we do this, see here it gives us the result. Now what is not possible in this big int is with the regular numbers. So let me just show you that here. Constant huge. So let's just say here some big number. Okay, and then here we have constant normal regular number, which is of 23. Okay, right now what we'll do is, let's just console.log, let's just say huge into number. So here it should be the huge and then number. So when we log in, see here it gives us the error because we cannot mix with the big int and other types. So for now, let me just turn this off for now. Okay, and this is where we then would have to convert this number here into the BigInt, and this is where the construction function that I showed you here becomes necessary. So for that, let me just copy this and then paste it down here, and then here we'll just convert this into the BigInt. So when we run this, see here, now this works. Okay, however, there are two exceptions to this, which are the compression operators and the plus operator when working with the strings. So let's see that we can still do a big int and then, for example, a greater than a normal number. Okay, so here let's just say console.log 20 and greater than 15. So for suppose when I do this, see here, this is true and it works. So, and also when I just copy this and paste it again, and then here we'll use the triple equals to 20. See here, this is false, but that makes sense because JavaScript, when we use the triple operator, it does not do the type corrosion. And in fact, these two values here, they have a different primitive type, and it is a regular and it is a big int. So this is the big int and this is the regular. Okay. So let me just do this once again. The type of 20n. So you can see here it is the big int. Okay. And also we'll just copy this and then paste it, and then here we will remove 1 equals to. When we run it, see here in this case it is true. We did with the regular equality operator, which is 2 equals to. So we'll just paste it again here, and then what we'll do is we'll just simply remove this, and then here we'll use the string. See here in this case also it is true. Okay, so here we'll write exemptions. this is one exemption that writes out here. So the logical operators are one exemption, and the other exemption is when we do the string concatenation. So let's say huge plus, and then let's write some string here. So for that, here we'll just write console.log huge plus some string here. Let's say is really big. So when I run this, as you can see here, we got our output. So you see in this case, the number is actually converted to string. So even with the big int number, okay. Now, one other thing that I didn't tell you up here is that also the math operations that we talked about earlier are not going to work here. For example, we cannot take the square root like this. So let me just show you here console.log math dot square root of 16, and see here it's not going to work. Okay, so let me just turn this here off. So it won't work. Finally, we see what happens with the divisions. So here we'll write so here we write the divisions. So we'll just say console.log 10n divided by 3n. So when I run this, see here it gives the 3n. Okay, so similarly, if we run this without the n, you can see it goes 3.3 and so on. So with the big ints, it basically removes the decimal parts of the output, as you can see here. Okay, and basically that is all that I have to tell you about in the introduction video, like this one about BigInt. So this new primitive type adds new capabilities to the JavaScript language. When you really need to work with the huge numbers now in practice, you will probably not use this very much, but it's still good to know about the BigInt exists and also how this works. Okay, that's it for this video.